The Caspian Sea is the largest landlocked water body in the world. It's filled by rivers draining a vast region from northern Russia to Iran. As we mentioned on another video, the Caspian Sea ecosystem is unique, contains many endemic species, and provides various ecosystem service to many millions of people in the surrounding nations and beyond. The Caspian Sea has been dominated by major changes in water level during the Quaternary, which reached an amplitude of around 150 meters, with the highest water level reaching up to 50 meters above mean sea level during the warm period, and as low as more than 100 meters below mean sea level during glacial period. This figure, for instance, shows potential source of runoff and flow directions between the Caspian Sea and the adjacent water bodies, including the Black Sea and the Aral Sea, that likely affected Caspian Sea level variation during the Quaternary period. Glacially induced changes to the Caspian's catchment topography has also led to alterations in the size of its water source areas, with a significant knock-on effect on Caspian Sea level, which is so interesting to know that this had implication on the Caspian Sea surface area, as the change in its surface area is highly influenced by the variation in its water level due to the shape of the lake bathymetry itself. So additionally, the area of the sea changes. It also has impact on the global climate, but there are significant questions about how and where those impacts would be felt, because this sea is very huge and its impact is beyond its catchment. To understand this, we used a state-of-the-art climate model in which we specified different sizes of Caspian Sea in order to examine how the climate changes as of its area increases. We considered 4 scenarios where large and smaller than present-day Caspian Sea area was used to emulate past changes. Current area and no Caspian Sea scenario were used as a control. Caspian Sea surface area affects regional climate over the catchment as well as large-scale climate over the entire northern hemisphere. What a very interesting result. For example, a large Caspian Sea enhances precipitation over the Central Asia, warms the northwestern Pacific during winter, and reduces Pacific sea ice. So the impact is very far from the area. Since the climate impacts are so significant and geographically extensive that climate models used to simulate climate change, both in future and past scenarios, should incorporate changes to the Caspian Sea area if they are to robustly model regional climates, as we have seen that it's very important in regional and large scale. Many climate models either ignore or do not properly prescribe Caspian Sea area with considerable variation, and this is a primary determinant in the modeled water budgets for both historical and future projections. So most climate models still poorly prescribe the actual Caspian Sea area, in part due to their relatively low spatial resolutions. This may bias its climatic impacts and introduce Iran in the Caspian Sea water budget for both historical and future projections. In global models in general, lakes, for example, the case of Caspian Sea, are either completely overlooked or included as a large, shallow pool of surface water, and this affects the heat capacity in storage. We have learned how important large lakes are in controlling regional and large-scale impacts. However, there are still more areas of research which needs investigation. Here at Baylor University, in collaboration with University of Texas, we are trying to incorporate fully coupled lake and climate model to further understand the lake effect. For anyone interested in the detailed results and methodologies we used, please check out links to our research and other videos in the links below.